Hello everyone, welcome back again. In today's tutorial, we'll be learning about numbers in Julia. So Julia is very useful when you are doing numerical computing. So it has some cool features already built into it. And let's see how to work with the basic syntax for numbers in Julia. So the syntax for numbers is that it follows the paired mass or paired mass precedence for the arithmetic operations. So let's say I have a value like x and then y, and then I'm assigning this x and y as 20 and then 5, right? That is a value that I have, 20 and 5, and I want to work with these things. So the normal sentence for mathematics, almost all of them works. So x plus y give us a value of the value that we need, 25. You can also do it for multiplication, subtraction. So multiplication, subtraction, all of them work perfectly. So can work on subtraction. It also works for division, multiplication, division, inverse division. Here's the normal, this inverse division, and then the one for normal division, which is very interesting in Julia. And also do the exponent with this particular characteristic. So if I work on this, it's going to work perfectly for us. Same for this, and then this is also going to work perfectly. And then the final one. So this is, you see the difference between this normal division and then inverse division, and we also have exponent, which is also going to work perfectly for us. So this is a normal division, which is going to give us, and this is the inverse division, and this is exponential. So that is how to work with this in Julia, right? Now that's not the only format. You can also put it inside a tuple and then let it work. So there's something like this. So plus, you put your operator outside, and I give the number like 4, and then let's see 5. It's also going to work perfectly for us. This format is also going to work. So either you can do it the normal way, you can put inside a tuple, and it's going to work perfectly for us. So it can be done for any number like 5 and then 4, and it's going to work perfectly for us. This thing can also be done in this format, right? Okay, so this is the normal one. So you can also work with other form of division functions like this. So you have diff, then I put the value there, let's say 12 and then 4. Here's a division function, is going to work perfectly and give us 3. You can also do floor division, which is, let's say 12 and then 12 is a floor division. You can also do inverse division, right? This is a normal division, the floor division. You can also do ceiling division, which is going to be CLD, the ceiling division, and it's also going to give us the number of 3, right? So all of these things are supported in Julia: floor division, ceiling division, and a normal truncated division. You can also do remainder or modulus. So if I do remainder of, let's give it a number that will give us a remainder 5, remainder of 2, and also do modulus, and then it's going to work perfectly for us. So 5, perfect, right? So rem, modulus, all of them work perfectly in Julia. So this same thing, and this modulus, right, could have been done in this format if we had something like s, and then with a percentage and then the value, right? It's also going to work perfectly like the normal way that we had. 0, right? So this is just the modulus, the same in this format. So that is, these are the division functions you can work with Julia. You can also do long division, LCM, this common multiple of, let's say 12 and then 36. It's also going to work. You can also do the greatest common divisor of a value like 30 and then 10, and it's going to work perfectly. So all of these things come already input. You don't need to import any package. It's going to work perfectly for us in Julia. Okay, so these are some of the cool stuff you can also do in Julia. So that's not all. We can also do normal square roots. SQT, square root of a number like, let's say 16, giving us the value 4. And also do cube root of a value like 21. It's going to give us all of these already inbuilt, right? Which is quite interesting. You can also do logs of a value, so log 100, or you can, if you want to get the log of a particular value, so log and then the value like log 10 of the value, right? This log to the power 100, which is going to give us the same value as the one we had previously, right? So this log 10 of 100. In case you also want log of a particular number, you can give it as the base, the number that you want to 4, and then our value, let's say what something. Oops, I made a mistake. Anyway, this is also going to work perfectly, right? So this is the base, and then this is the number that we are raising to. So all of them work perfectly in Julia. So these are some of the things you can also do. In case you also want to do hypotenuse, you can do hypots, then supply the value of s and y. So the value of s and y is going to calculate the hypotenuse for us in Julia. So these are some of the things you can do in Julia concerning numbers. One nice thing about this, this is just a basic arithmetic, right? You can also chain your values together. So in case you are doing something like this, something plus, right? You can do plus, then I can give a number like 2 by 5 plus another value, right? All of them is going to work. So you can also minus 4 is also going to work. You can also put it into tuples and it's going to work perfectly for us. That is very interesting, very nice in Julia. So thank you for watching this number about numbers. Now let's see again about floats. So how do we work with floats, integers and stuff? So to check for a value in Julia, let's say you have a value in Julia, you want to check for the type of the particular value. So let's say I have a value like a. Let's give a as 12, right? If I want to check for the particular type of this, I just go with type of, then I'll put my value there, the value that I have, which was a of my variable, right? So if I go with type of, it's going to give me a particular type, right, or data structure that is, which is in 64. So the 64 is the system, which is very interesting. So if I give it a different number like type of a value like 4.6, this is going to give us a float, right? So this is going to give us a float, right? Float 64. That is quite interesting. So this is float, integers, and then you can also have several other stuff that is also supported. So we did something like this. So I have something like b for float, and I give number like 4.7, right? If I check for the type of this value, which is going to give us a float, I can also do some cool stuff inside this. I can just go with prev, right? Pre-float. If I go with pre-float, it's going to tell me the previous float number for this might be, which is going to give us as 0.669, which is very interesting. If I want to get the next float, I can go with next float and then b, then I'm going to give my next float, which is 4.7, which is interesting. So that is some cool stuff you can also do with float in Julia. Okay, so that is about float. Now let's also talk about rational numbers. So rational numbers in Julia can also be done. You can also do rational numbers. And then examples of some of the rational numbers you can also do is that you can do something like this. Let's say 2. To do rational numbers 2 and then the value like this, right? So let's put inside the value. Let's put it r and 2 by 5, right? Something like this. So this is going to be a rational number, and then it's quite interesting. So in case I want to find the value of this, right, the upper, whether it is denominator or numerator, you can also do that in Julia. So how do I do that? Just go with denom, right? Denom of r is going to give me the denominator, which is going to be my denominator, which is going to be 5, right? In Julia 0.6, we couldn't have done that. In Julia 0.6, if I have a value like r, it's going to be 2 by right? 2 by this. If I want to find the numerator of this in Julia 0.6, I have to do the value. I have to do den and then the r, but before I can get the value, so it is den, that is a short form, right? Denominator, that will give me my value. So that is the denom is deprecated, right? Use denominator, right? So that is for the previous version. And then if I wanted to do numerator, just go with denom and the r, then it's going to work, right? That is how to do it. But in the current version, we don't do this. This is for the new version. So in case I want to do numerator, just go with numerator, then my value. So this is how we work in this current version 1.0. The old version is din r and then num r, right? These are for the old version, but this is for the new version in Julia 1.0. So this is what you can do in numbers. And let's do one last thing, then we'll be done. We can also In case I want to do vectorized dot operators in Julia, let's say I have a value like 1, 2, 3, 4, 5, right? And I want to add a number to each and every of them, right? So the simplest way is to go with the dot, right? Which is very interesting and very powerful. The dot operator, dot, and then your value, your operator, your arithmetic operator. So dot plus. So I want to add plus to it, or I want to raise to the power 2. So if I do plus 5, it's going to add 5 to all of these numbers. So that's printed perfectly for us. So it added 5 to 1, 6, 5 to 2, 7, 5 to 3. It is very interesting with this dot. That is one nice thing and very powerful thing about Julia. So this same thing can be, in case I wanted to do the same thing for raising to the power of something, I can do the same dot operator to the power 5, and it's also going to work, and then raise them to the power 5 for us, which is given us. If you click on this, going to print it perfectly for us, which is quite interesting, very powerful. So these are all already built into Julia, making it more powerful for numerical computing. So thank you for watching. If you have any question or contribution, you can just put inside the comment section so everybody can benefit. And please don't forget to subscribe. Stay blessed.